Hi folks, we're going to take a look at page 75, number 17. So let's take a look at the question. Find the work done by a 30 Newton force acting in the direction of the vector -2, 1, 5, which moves an object from A 2, 1, 5 to B 3, -1, 2. The distance is assumed to be in meters. Okay, so got the information written out here. Now, it's a work problem. Okay, dealing with force and displacement. However, all the information seems to be given to me, at least most of it, in algebraic form. So here we're given the starting point and end point as points in 3 space, the direction of the vector given as an algebraic vector. So this tells me that I should be trying to solve the problem using the algebraic definition of the dot product, which we'll use to find work. Okay. So we'll start with the displacement here, because that, I think, is probably the easiest one of the two. So here it's moving from, okay, and here since it's moving from A to B, the assumption is that this is point A to point B, not vector A to vector B. So the first thing I'm going to do is the displacement vector will just be the vector from A to B. So let's calculate that, and we know that when we're finding the vector from one point to another, it's the second minus the first. So here it's 3 minus 2 is 1, -1 minus 1 is -2, and then 2 minus 5 is -3. Okay, so there's my displacement vector. Okay, now we have to find the force vector, and this is, we have to be careful as to how the information is given. They give us the magnitude of the vector. And the way they describe the direction is they say it's in the same direction as this vector here. Now, if you were to calculate this, the magnitude of this vector is not 30, so this is not the actual force vector. It just gives me the direction. Okay? So how am I going to use the direction of this vector but incorporate the magnitude that's given to me? Okay, and if you think about it for a while, hopefully you come up with the idea of using the unit vector in this direction. Because a unit vector will have magnitude 1. Once I have that vector, I can just multiply it by 30 to get the correct magnitude and the correct direction. So let's find the vector, unit vector in the direction of -2, 1, 5. Okay, and the way in which we can create a unit vector in a given direction is just by dividing by the magnitude of this vector. Okay, so -2 squared plus 1 squared plus 5 squared. Okay, and so here we have -2, 1, 5 divided by, so 25, 26, and 4 is square root of 30. Okay, so my unit vector in the direction of -2 and 5 is -2 over root 30. 1 over root 30, and then 5 over root 30. But this just represents the unit vector in the direction I want to go. If I want the force vector, okay, I need to multiply this unit vector by 30 so I get the correct magnitude. So 30 times -2 over root 30, okay, 1 over root 30, and here 5 over root 30. Okay, whoops, that was times 30. Okay, so what do we have? We have -60 over root 30, 30 over root 30, and 30 times 5, 150 over root 30. Okay, and now I can find the work, and that's just F dot D. Okay, so I have F is this vector here. And dotted with 1, -2, -3. Okay, so let's calculate that here. 60 times 1, so we have -60 over root 30 plus, okay, this will actually be a subtraction here because we're multiplying positive by negative. So here we have -60 over root 30, and then here again minus 150 times 3 is 450 over root 30. Okay, and let's simplify this here. So negative, so 450 plus 120, so that's going to give us 570. So this is -570 over root 30. Okay, and as far as I'm concerned, we can leave it like this, and this will be the answer in joules. Okay. However, if you did want to, as the book does, rationalize the denominator, we know that we would multiply top and bottom by root 30. Okay, so the denominator just becomes root 30 times root 30, which is 30. Okay, and this is negative 570 root 30. Okay, and this can actually be simplified. Okay, so 57 divided by 3 is just, let's see, that would be 19. Okay, so this is negative 19 root 30 joules. Okay, now, in fact, what I would prefer in an example like this where there's a physical context to it, okay, I certainly wouldn't mind actually seeing an approximation, since normally when we're working with a some kind of physical example, we'd like to see an approximated answer. So times root 30 equals, and that's about negative 104 joules. Okay, and that's it. But let's review here. Okay, because the information was given in algebraic form, that told us we should use the algebraic definition of the dot product to find work, which in this case here is as we did. And we use this idea of using a unit vector to represent a direction, and then we just multiply that unit vector by whatever magnitude we need. In this case here, a magnitude of 30. Okay, that's it for this question.